Hello everyone, this is Maria Rangwala. In today's video, I am going to discuss about Apache Hive, a tool in Hadoop ecosystem. The objective of this video is to understand what is Apache Hive, features of Apache Hive, architecture and working of Apache Hive, and an example to understand HiveQL. So before we begin with Apache Hive, I will give you a brief description about Hadoop. Hadoop is an open source framework that is used to store and process large amounts of data. It has two main components, Hadoop Distributed File System and an MapReduce. In the Hadoop Distributed File System, we stores the file into clusters. It has the data node and the name node. Name node stores all the metadata about the files, and the data node stores the actual file and has its replicas in it. The MapReduce function is used for processing of the data. We have the map function, reduce function, and it has the job trackers and the task trackers. So now, what was the challenge faced, and why do we need Apache Hive and Hadoop, and why was it developed? So Hadoop is developed and works on Java, and so does MapReduce job. That also works on Java, which is difficult, time consuming, and requires more programming skills. So it was a lot more difficult for the analyst and the business user to understand it. So we needed an SQL-like structure query so that the users and the analyst could easily work with it. So here came Apache Hive into the picture. Apache Hive is a data warehouse built on top of Hadoop ecosystem. It provides SQL-like interface to query, analyze large datasets easily. Initially, it was developed by Facebook, and later Apache took it and developed it as its own feature under the name of Apache Hive. So the features of Apache Hive are if one wants to extract, store, and transform or load petabytes of data stored in HDFS, they can use Apache Hive. It is a mechanism to impose structure on various data formats. Using Hive, one can access data stored in HDFS or other storage systems such as HBase. Apache Hive provides an SQL-like language known as HiveQL or HQL to help and make it easier for SQL users to learn and use. Apache Hive is fast, scalable, and extensible tool. It also supports partitioning and bucketing. So now, moving forward, we are going to discuss the architecture of Apache Hive. So, the architecture of Apache Hive has five main components, that is the user interface, metastore, HiveQL process engine, execution engine, and the data storage. The user interface helps us to interact with the Hive. So we have three main components through which the user can interact. First is the web UI, through which the user can directly interact with the web UI that is available in HiveQL. Then we have the Hive command line, and finally an application that is HD Inside. Now, we have Metastore, that is the heart of Hive. The Metastore contains all the information about the database name, schema name, table name, and the number of columns in the table, what is the data type of the column. These are all the information that are available with the Metastore. That is, it gives us all the metadata about the database or the file that we are creating on Hive. Then we have the HiveQL process engine is used to process HiveQL queries. If user has written HiveQL query and wants to process it on the HDFS directly, it is not possible because HDFS only understands MapReduce. So we need to convert HiveQL queries to MapReduce program, and then we execute those on HDFS. So here comes the execution engine. So what it does is HiveQL queries written by user are converted to MapReduce programs, and they will be executed on the HDFS or the HBase. Once the data is available, and it will be given back to the Hive, and it will be converted into the HiveQL by the execution engine. Moving forward to the working of Hive. So the working of Hive basically goes in this format. First, with the help of interface, the user interacts with the interface and gives a command to the driver. The driver then, maybe JDBC or ODBC, it will send the queries to the compiler. The compiler will check the syntax and ask the metastore about the database name, schema name, table, etc. If everything is fine, the metastore sends a reply to the compiler, which in turn the compiler sends to the driver, telling that everything is fine and that they can continue the execution part. So now the driver will send a request to the execution engine, which does a particular query execution. If now the execution engine once again sends a request to the metastore to check if the queries are correct and everything is all right. Once they receive the database information, table name, and everything, they once again continue the execution. And then a MapReduce job and a MapReduce program is made by the execution engine, which is sent to the HDFS cluster. The HDFS cluster processes it and gets us a data, which again comes to the execution engine. It converts into HiveQL format, sends it to the driver as a result, and the driver then gives an output to the user. So that's all about the working of Hive. And now we'll see. So now we'll discuss an example of HiveQL execution. So before you try to execute HiveQL, you need to install Hive on your system, for which you need to go to hive.apache.org and download a zip file and extract it and set it as the home directory for Apache Hive. Now then, after you have completed the installation part, you will run this command to check if the Hive is installed correctly. If everything works fine, you will see a prompt like this on the command line appear. And if you see this, everything's fine. Now we'll just see a basic example on how we can define a table in our HiveQL. So for that, we'll write a prompt, data definition language prompt, that is create table class. Here, class is the table name, roll number is the parameter name, and int is the data type of the parameter. Here, name is again a second parameter, and string is the another parameter type. Then, if you want to see how many tables are available and if this query has worked fine, you will see an OK appear. And then if you want to see if how many tables are available in your database, you will run this command to show tables, and you will see this table has been created successfully. If you want to drop this table, you'll basically write drop table class and the table will get deleted. Now next we'll see another example on how you can create a database in HiveQL. So to create a database in HiveQL, you'll write create database, and we write if does not exist for the purpose to check if the database already exists, like user DB already exists, then it will not create a new database. But if it doesn't exist, it will create a new database name as user DB. So now we'll check if the database has been created or how many databases are available to us. We'll write show databases. So this will tell us how many databases are available, and it will give us the entire list of all the database available in our system. Now next, if you want to drop a database, so you'll just write drop database and the database name. And here we have written if exist to check if the database exists, then only it will delete. Now we have an alternative method to drop schema. That is, we can write drop schema user DB. So this will delete a schema from a system. Next, we'll see an example of a lot more elaborated query written in HiveQL. So this is a query which shows how you can create a table and along with a few optional parameters. So here we have written create table to create a table, and we are checking again that if a table exists or not. Then we have written the table name employee. Here id is a parameter, int is its data type, name is another parameter, string is its data type, salary is a parameter, and string is another data type of it is a data type of salary. Destination is also a parameter, and string is its data type. So here we have written comment. It is an optional parameter which basically tells us the description about the file. So comment here tells us that this table that we have created is an employee details table. So it helps the user to easily read a query for those who don't understand technical part of it. Then we have row format, delimited fields terminated by tab. So this basically tells us that the row fields will be terminated by a tab. You can write anything over here in place of tab. It can be other escape characters as well. So then we have line terminated by /n, which tells us a new line will be entered here. Stored as a text file, it tells how it will be stored in our system. So now we can execute a few queries for the modification in here. So based on this query that we have run us now, and we have created a table, we'll be working and manipulating a few things over here. So for querying of this, we usually do select query select, which helps us to select a particular kind of query or based on our conditions. So yeah, we are going to select the ID and the name from the employees table where salary is greater than 40,000. So this will give us all of the employees ID and names who have their salaries greater than 40,000. Then if you want to rename a table, we'll use the alter table employee, that is a table name. Then we'll rename it. Even then we'll use the keyword rename to so that we can rename it to M. Then to drop a table, as we have already seen, we'll write drop table, then the table name. So with this, we come to the end of our video. So finally, in this video, we discussed what is Apache Hive, features of Apache Hive, architecture and working of Apache Hive, and an example. Hope you all understood it, and thank you for watching.